right. Good afternoon, everybody, and thank you guys for being here. Welcome to our April 2025 installment of ENERCALC Office Hours. Got a great program for you guys to hear today. And as always, we're going to get started with some housekeeping items just before we start the main content of our program. So before we start, I want to begin with a quick sound check. If you direct your attention to the bottom menu of your Zoom window in your browser or desktop app, you'll see the chat tool. You'll also see the reaction emoji down there. If you're able to hear me right now, just go ahead and throw a thumbs up emoji in the chat. Give us a thumbs up, give us an okay. Let us know if you can hear me all right. Perfect. Thank you guys for confirming that. And before we get on to the rest of our introduction, I want to start with a sound check and visual check for our primary speaker as well. So Mac is going to go ahead and share his screen, which you all should see now. And then once again, if you can hear Mac's voice in just a moment, go ahead and give us a thumbs up or an okay in the chat.
Hi, everyone, and welcome to Office Hours. And please let us know if you can see our screen.
All right, beautiful. So now that we have our tech checks out of the way, we are going to go ahead and disable our chat for today, and we'll move on to some introductions and get going with today's program. So my name is Seth Roseworm, Senior Structural Engineer and Software Developer here at ENERCALC. Our presenter for monthly office hours today is Mac Elterhony. Mac is a senior structural engineer here at ENERCALC. He kind of splits his time between providing technical training for ENERCALC customers, work with the ENERCALC engineering team on the specifications and behavior of our software, and also helping maintain a presence for ENERCALC at national and regional events throughout the U.S. So Mac's a founder and managing principal of Elta Design Group, which is a specialty structural engineering firm based in Oklahoma City, Oklahoma. And he's been an ENERCALC user for about a decade, so he has a lot of great insight about the needs and daily workflows of our customers. For anybody who's new here this month, welcome to our recurring office hours webinar series. These sessions are meant to provide direct communication between our engineering team and ENERCALC users, and we do that through several avenues. We showcase new features and updates from ENERCALC so you guys can stay up on what's the latest stuff that we push every month. We answer questions submitted by customers or users that are sent via email. We also do live Q&A and go through hands-on examples. And then we show optimized design workflows on specific modules that you guys use every day. So if there's ever a question that's too involved or it requires deeper digging, that might be a better fit for our support team as they can investigate your concerns, look under the hood, and get you better answers about deeper troubleshooting questions. As a minor point of order, you will notice everybody's microphones are muted just to make sure we don't get any echo or feedback while Mac is presenting today. And as I mentioned, we do have open Q&A at the end of every office hours session. If you want to submit a question for today's Q&A, use the Q&A dialog in the dashboard of your Zoom window. If you experience any audio problems at any point during the session, you should be able to simply refresh your browser or simply get out and rejoin the session to resolve that, as well as using the native Zoom audio controls in your dialog. If you ever need to rewatch today's program or you want to share it with someone else on your engineering team, all those recordings are posted on our Office Hours playlist, which you can access either through our website or through our YouTube channel. And with that, I will go ahead and hand it over to Mac to get us going on our program for today.
Thank you, Seth, for the introduction. And again, welcome everyone to our April installment of the Office Hours program. As Seth said, my name is Mac Elterhony, and I am excited to be presenting to you today about a couple of our miscellaneous modules in ENERCALC, diverse library of extensive calculation modules. And we have a lot of updates today, so let's get started. So first, I'd like to start our session with a brief overview of our overall agenda. We will be, of course, going over ENERCALC latest updates. We're going over the what's new with ENERCALC, and we do have a lot of exciting updates today, a lot of exciting news. Then we have the steel base plate design module and the bolt group analysis module. Then we'll go over registering for office hours to get notified for future installments, future sessions, and of course, live Q&A at the very end of our session. So first, would like to encourage you all to check your software to make sure that you are on the latest build of ENERCALC. So if you could take a minute, open your software, and all you need to do is just look at the very top and see the build that you're on. And we do release monthly updates, so we want to make sure that you are using the latest and greatest of what ENERCALC has to offer. We commonly receive questions in our on our support line, and a good majority of those questions are things that already have been addressed in recent updates. So always make sure that you're working off of the latest and greatest. That most of the times will fix many of the problems that you might be facing. Otherwise, again, you can always just email us at support@enercalc.com. So our current build as of today is 2025 3.4, which is March 24th. This is the latest build that we currently run. And to update ENERCALC, just at the very top of your program, there's this icon right here that says the update button. You can click on that, and what happens that it'll take you to this window right here, and you can click on this button that says click to launch for our users page. This will take you to our website, and you can click on the second link that says click to download the ENERCALC updater. So this is just an update pack. This is not a fresh install. So this is a very quick thing to do. Maybe takes like 2 or 3 minutes max from start to finish, and it will download everything for you. And then once you download it, of course, you can just run it, and it's very quick. Additionally, make sure you always check the option to automatically check for updates. And this way, as soon as you open ENERCALC, it will notify you of new updates to the software. And if your software or if your ENERCALC is stuck in one of these builds, so anywhere between 2023 830 and all the way to 2024 228. If you are in this range, then you have to do a manual update. It's a one-time thing. You just do a manual update because the feature that notifies you of new updates, that automatically notifies you of those new updates, that feature is not operating properly if you are within this range. If you're not, then you're good to go. And again, the current build of ENERCALC is the March 24th release right here. So if you prefer to be notified of the latest ENERCALC updates by email, then all you have to do is just scan this QR code or go to enercalc.com/update dash emails and just put your information here, and you'll always get an email that tells you, hey, we released a new update. So you'll have an email of that if that's a better way of communication for you. Now, if you have not been using, the latest and greatest of ENERCALC, or you haven't had the chance to poke around some of the new features, we wanted to highlight some of the new functions that we have added recently and updated so you can take advantage of. Of course, the past few months we have done this, which is the decoupling of the IBC and the ASC. So this is due to some jurisdictions asking to mix and match IBC editions with ASC edition. So they might want to use IBC 2015, but they want to use the latest and greatest ASC. So they want to use ASC 722. Before that, we were just lumping up everything in one spot. So based on the IBC you use, it'll grab all of the codes or the design standards that are referenced under it. But now you have the ability to select IBC code different from the ASC design standard. And this will provide you hopefully more flexibility in meeting the jurisdictional requirements that you have to adhere to. The second update, which is also regarding the ASC 722 modules, and I'm sure by now everyone has noticed all of these additional updates under the add a calculation or add calculation menu. So the first tab is the seismic loads tab, and in here we added calculation modules for seismic base shear, seismic wall anchorage, and seismic demands on non-structural components. The next tab is the wind loads tab. Currently we have the ASC 722 directional procedure, envelope procedure, and we do have the wind enclosure, and again, component cladding, which is Chapter 30 of the ASCE, is under active development. So whenever that gets released, it will be housed under the wind loads tab right here. And of course, the last tab is the other loads tab, and that's where we add other loads such as live load reduction tool or a for example, snow loads here for snow loads and snow drift calculations. All of that is housed under this module right here. All of this under the other loads tab. Of course, another exciting update that's been going on now for a couple months is the ability to link reactions, which we call it load linking, natively within ENERCALC. Load linking gives the user, of course, a huge amount of flexibility to automatically link reactions from one calculation to another, and the ability to change something in one member and have those effects of that change, trickle down all the way to the supporting members downstream. So this was one of our most requested feature from our users, and we are excited that load linking for steel beams is obviously has been released for months, and many other modules are currently under active development. And the exciting news that we shared last month is that wood beams are now included in the ability in the load linking um, uh, function or feature. So now you can link loads between wood beams. You can link loads between wood beams to steel beams and the other way around. So from a steel beam to wood beam. So you have the flexibility to go back and forth between all of that, all of these modules. And in this example, we already have a steel beam one, as you can see right here. We already created that, and we already created wood beam one. And we are working on a new calculation, which is wood beam 2. Think of this as a girder. So you'll be able to see those members now, wood beam 1 and wood beam 2, already displayed under your table here on the left-hand side, and you can grab whichever member you would like and grab a reaction from it. So when you click on whatever member you would like, and you can see right here the 0.96 and 0.87, that's reaction from support number 1. That's already added right here, and you can just simply add it by following just the simple prompts here, and it shows automatically in your 2D sketch. And in the same calculation, you can click on wood beam 1, and the 2D sketch will change to reflect that calculation. So once you link the reaction from support 2, for example, it will automatically again display right here for you on the 2D sketch of the new beam, which is beam number wood beam 2 that you're designing. So the engineers at ENERCALC understand that load linking or linking reactions from different materials is critical in common, and we want to give our users, of course, the ability to mix and match. So we're also mindful of load linking interoperability as we continue developing more integrations into our modules. And the user here has the same capabilities in terms of placement of linked reactions, just like what we do before in steel beam. So you'll have the ability to put the load at a midspan or third points or all of that. So you have all of your capabilities that you have in steel beams. Now you have them in wood beams as well. And the standard load linking features are of course, still functional after the wood beam integration. Just a similar way that you would typically expect. You have the calc order tab that brings all of the linked calculations together and puts them in the load path order. If beam 1 is sitting on the girder and the girder is sitting on transfer girder 1, then transfer girder 2. Depends on how these reactions are linked from one calculation to another, you will get the proper load path order, and you'll have these calculations listed in that load path order to make sure that everything is performed properly. And of course, at the bottom, you still have your status badges right here that shows you that if it's green, then the calculation is up to date. And then, you have the orange and the red warnings. And of course, the last item here is that the very top, which is the recalculate linked loads button. That's whenever you change something in the first beam, and now you have 3 or 4 or other, maybe 5 calculations or 5, downstream members got affected by that one member that you changed. So you don't have to go and re-update the calculation individually. All you have to do is just say recalculate linked loads, and ENERCALC is smart enough to know the load path and perform those recalculations in the proper load path order to make sure that all of those effects are trickling down to the members downstream. So overall, load linking is a powerful tool that allows the engineers to create a well-connected chain of calculations while minimizing the risk of transcription errors. And of course, now supporting steel beams and wood beams is definitely a great addition that's been going on now for a couple of months. And of course, if you'd like to learn more about load linking, please check the load linking playlist on our YouTube channel. So you just go to ENERCALC software on YouTube, click on playlist, and this is one of the items that will appear here. There's load linking. The playlist will walk you through how to use load linking step by step in a real example where you can leverage this powerful tool and understand all of the ins and outs of it and all of the warnings and what they mean. Now, the newest news about this that just came out here in our newest update, March 24th, is that ENERCALC now supports load linking for steel columns. So that is now the third module that supports load linking. So this is, of course, yet another exciting development that showcases and demonstrates our commitment to expanding the native load linking feature in ENERCALC to make the process of carrying loads and managing design changes as smooth and accurate as possible. So pretty much if you, again, if you have the latest and greatest ENERCALC, and if you open any steel column calculation, you can now see the new tab right here that says linked loads. And you can follow the same simple and intuitive process that we use to link reactions. So it's the same process as we have before in wood beams and in steel beams. Now you have that in steel columns. So you'll get here all of the other calculations have already been created. So we have a bunch of beams that we created here, and you can grab whatever reaction from the beam, and then you can apply that with eccentricity, and you can do all kinds of stuff that you can typically do with the steel column module. So this is just another integration that you can take care that you can utilize for your future projects. So I encourage you to update to the latest version of Revit, latest build of Revit of ENERCALC. And use that. So we also another update is training videos. So we also created additional tutorial video playlists, and they're posted again on our YouTube channel. These playlists are easy to digest and provide a step-by-step information on how to use ENERCALC. So these playlists that we recently updated, one is for the composite steel beam module. So this goes through the various options, the loading and all of that, and how to read the results and how to model everything and the various options with correlation with the code as well. So this is very useful. And then the other one that we created recently is the soldier pile retaining wall module training video. So that will take you through the whole process of how to go, how to use this module and understand its capabilities and limitations. And of course, we're going to have more tutorial playlists to come. So another update, yeah, it's been a busy month here at ENERCALC. So another update is the incorporation of the IBC 2024, and now that is supported as a governing code option. So we will continue to support IBC 2015 as well to provide our users with, of course, as much flexibility as possible to be in compliance with the jurisdictions that have not caught up to the newer editions of the IBC. I'm personally located in Oklahoma, and I work in a few adjacent states, and I still get projects, my company, where we have to use IBC 2015. So definitely hasn't died yet. So ENERCALC is making sure to keep that for our users. And to update your project to use IBC 2024, it's pretty simple. Once you open your ENERCALC, once you open a project, at the very top, you can find here the building code and load combinations tab. If you click on that, it will actually display this window that we're seeing here in the back right here. And pretty much all you have to do, just pick the IBC that you want, and of course, click Save and Close, and you're good to go. Now, keep in mind that this will change the code only for the current project that you're working on. That's only for the current project you're working on. So if you need to change, you know, ENERCALC to use IBC 2024 as a default for all of your future projects, then the way to do that is to go to the very top left corner, click on Settings, and then click on Default Governing Code and ASCE 7 Editions. This window will pop up. You can choose the IBC that you want, and of course, you can choose the edition of the ASCE that you want, and you click Select. This will ensure that all of your future projects will start with IBC 2024 as a default. So that would be something that if you want to change it for all of your future projects, that's how you do it. If you want to change it from for just a specific project, then you can just do it from the building code and load combinations button. The last item I want to highlight before we get into the steel baseplate module is ENERCALC for Revit. ENERCALC for Revit is a Revit plugin that allows you to design structural members fully within Revit. You don't have to export any information. You're not exporting stick modules or stick analysis, stick frames, or any of that stuff to another calculation software. You practically doing everything from within Revit. It's a simple point and click, as you can see here, and it allows you to design a member, of course, in a fraction of the time. All you have to do is follow simple guided prompts that will take you through the design process, and before you know it, you will be done with the design. It's that easy. And currently, EFR or ENERCALC for Revit supports the design of steel beams, steel composite beams, wood beams, steel columns, and foundations. So that provides, of course, a full gravity load path for you. And of course, more is already in development, and it's underway. And while we're on the topic of ENERCALC for Revit, it is worth noting that Autodesk released Revit 2026 on April 2nd, 2025. So that's exactly 1 week ago. That was last Wednesday. And I'm excited to share today that ENERCALC already released the update for ENERCALC for Revit product, which provides support for the 2026 Revit. We know that, of course, our users rely on our software for their daily engineering tasks, and we want to make sure that ENERCALC is never the bottleneck of your production line. So we issue, of course, these monthly updates to make sure that everything is updated as much as we can, and to make sure our users are best equipped to handle their daily tasks. So this update just released today for ENERCALC for Revit. So for our users who have ENERCALC for Revit, they are ready to go. If they have a project that uses Revit 2026, they are good to go. Once they have this update installed, they will be able to move on with their production. So moving on, the focus of our session today is the design of steel base plates in ENERCALC based on the second edition of the AISC Design Guide #1. So that is the first topic that we are going to discuss today. So here's a quick overview of the capabilities and the features of the steel base plate module. You can perform analysis of steel plates as well as anchorage forces, so anchor design, or the forces that goes into the anchors. Ability to apply axial loads, shear loads, and moment loads as well. So next you will have, of course, your dynamic 2D sketches and 3D sketches for visual confirmation, and results include max tension per bolt, and that is very, very critical. So we're gonna have this example that we're gonna go through today, and our example is that we need to design a base plate or examine a base plate that is 24 inches by 22 inches. So the N dimension is 24, that's the length of the plate, and the width of the plate is 22 inches, and we want to have an edge distance of 2 3/4 inches. We have concrete support below the base plate. This is just a pedestal that is 24 inches by 22 inches. So a pedestal that's exactly the same width as the base plate. We have a W12 by 96 column. F prime C for concrete is 4 KSI or 4,000 PSI. ASD factor of safety, of course, for steel is 1.67, and the ASD factor of safety for concrete is 2.31, and those come directly from the AISC design or AISC manual. And the applied load is 50 kips axial, and we have moment, and of course, moment of 120 kip feet. And we are using a 1-inch diameter rods and grade 105. So this is what we're using today to make our evaluation of this base plate. So to start a new base plate calculation, we follow the same familiar process. You click on the Add button, and then you navigate to Miscellaneous tab, and you click on the Steel Base Plate to open the new calculation. So again, the same standard process that we use this, for all of our modules. We work our way through the tabs from left to right, starting at the General and Materials tab right here, all the way at the top left. So first, we give our calculation a unique name. I'm giving it a name here: example base plate AISC design guide number 1, axial plus large moment. If you're familiar with the design guide, there are different methods and different calculations. So you have, axial alone, you have moment or bending alone, and then you have axial and large moment. You have axial and small moment, and of course you have axial and biaxial bending. So we here, this particular module does not handle, just to make sure that we're all on the same page here. This module does not handle biaxial bending, so that's not going to be, this will not be able to do it. And the second thing that it does not handle, which is the net tension. So if you have net tension or net uplift, pure tension on your base plate, this will not be able to handle it. However, it handles the other conditions whenever you have axial alone, of course, small moment, large moment. It goes through the various calculations. For our example, I just went for axial with large moment because that's a little bit more fun. So that's kind of the first part here, the disclaimer and the limitation of use and the capabilities, so you know what you're dealing with. Moving on, this is very simple. You just pick your design methodology, and we are picking here full bearing because we want to make sure we use just full bearing analysis. And the next item we have here is the plate material. So it asks you for what's the FY of the material. I'm using 50 KSI. You can use 36 or whatever your example or whatever you want to use. And this automatically brings up the omega with the factor of safety for steel, 1.67. And if you are using LRFD, then you will get, of course, the phi factor for steel of 0.9. So again, whichever design methodology you end up using. Moving on, we have the concrete support material. We know F prime C is it's 4 KSI. And the information here, this is automatically calculated right here, which is the nominal bearing based on the AISC equations. And right here, the omega factor for from section J.8 from the AISC, which is the connection section, the omega factor is 2.31, while if you have the LRFD, then of course the phi factor will be 0.65. These are automatically populated for you but you can override them. So the 2.31 and the 0.65, those can be overridden if you want to. However, the omega for steel right here, for example, and of course the phi for steel, which is the 0.9, those are pre-populated and you cannot modify those. So we move on to the next step, which is the column and plate tab, and now we want to give a little bit more geometry. So we have three items that we have to input here. More information about the section we're using or the column that we're using, more information about the base plate, and more information about the concrete support, which is, in our case, it's the pedestal that we're using. Sometimes it's a foundation. It could be many different things, but whatever concrete support you're using, if you have a column on top of a beam or whatever. So that's the third part that you have to input. So with that being said, starting with the first part, in our example, we have a W12 by 96. That's what we need to use. So we simply click on this button right here so we can get this lookup button will give us this new window, which is the database. You can select the type that you want to use. So for example, if it's a W section, if it's a channel, if it's an HSS, so you choose whatever you need to choose from here. And then based on that, in our case, we're choosing a W section, and then you can kind of scroll down until you reach to a W12 by 96. Once you do that, it automatically populates your your geometry, so you don't have to worry about that. So that's the first part, pretty easy. Moving on to the second part, which is the plate dimension. So if you're working something from scratch, you need to have trial dimensions. You have to come up with trial dimensions. The ISC design guide has some recommendations on how to determine initial trial dimensions. But with ENERCALC, you can just plug and play until you come up with something that works for your project. As well as, of course, works from an engineering perspective as well. So if you have a column size and you be like, hey, I use a 12 by 12 base plate, or I use a 18 by 18, or whatever you typically use, you can start with that and kind of move forward until you converge on a solution that makes you happy and satisfies the engineering requirements. So the guide uses N for plate length and B for plate width. And ENERCALC is consistent with the AISC nomenclature. And additionally, what ENERCALC here does is that it provides you this sketch right here. And I kind of blew it up a little bit so you can see it enlarged. So this sketch kind of makes it easier for our users to visually correlate the labels with the input dimensions. So based on the example, the end dimension of the plate is 24 inches, which is right here. So that's the length. And the B dimension, which is the width of the plate, is 22 inches, which is right here. And then you can enter a trial thickness. You're just kind of putting different thicknesses and trying to see what would work for you. So this is, again, also as a plug and play to determine the thickness that you need. Maybe you want to start with an inch or inch and a quarter, or whatever that might be. So anyway, so you move on from this to the last item, which is the pedestal or the concrete support geometry. The example assumes concrete pedestal that has the same dimensions as the base plate. So the length along the Z direction, and this is important here. So length along the Z direction, that is going to be the same as N. So length along the Z, which is this one right here, the same as N, which is 24. And then length or width along the X, this is the X right here, the width along the X, that's going to match the B dimension, which is 22. And now we have a pedestal that matches the base plate dimensions. ENERCALC is all about empowering the users with dynamic and powerful visuals that update in real time to allow the user the ability to check their input data in multiple ways. Some people, they like to see what they're modeling. Some people are just good with spreadsheets and they can build everything in their head with just cells and numbers. So we try to work things out for all of our users. So if you click on the 2D tab on the right hand side, you will have an accurate sketch, 2D sketch with base plate dimensions that match your specific input data, as well as the proper orientation of the column, and a visual location of the anchor bolts, anchor bolt placement. So you can see that it already is telling you that the column size is W12 by 96, and you can see the plate dimension. This is the 24 inches, and this is 1 foot 10, which is the 22 inches. It is important to note that the sketch also shows the concrete support. However, in this condition, because the concrete support has the same dimensions as the plate, you're not seeing that right here in the plan view. So I want, kind of for just demonstration purposes, I want to change the support dimensions to 4 feet by 4 feet, so 48 inches by 48 inches. And what happens is that the 2D sketch is going to look like this. So you'll get here the dimensions for the plate by itself, and now this is the dimension for your concrete support 4 by 4. We don't have this condition, but I just wanted to note it, so this way you know that the visual depiction shows both the plate and the concrete support. Moving on to the next tab, which is the applied loads tab, you can apply axial load, shear loads, and of course moments. The sign convention is clearly explained, and we have it here explained visually and verbally to make sure that there's no confusion. So we have 50 kips axial load, and if you apply positive 50, that means ENERCALC will take that as the load acting downward. That's why it's shown right here. So it says P, which is the axial load, gravity load, plus sign is downward. So if you put a negative sign, then that means it is uplift or pure tension. Positive value for shear, if you put positive value, we're not putting anything for shear in this example, but of course, what's a base plate without shear, right? So we don't have that for this example, but you can apply it, no problems. But a positive shear, that means it points towards the positive z-axis. Negative shear, it will point towards the negative z-axis. And the next thing we have positive moment of 120 kips. Positive moment means that it applies pressure or creates higher soil pressure at the positive Z edge. So it's in that direction. So if it's negative, then it flips. It applies, of course, higher soil pressure at the negative Z-axis edge, which is all the way in the back there. So again, for us, we're just going to use positive 120, which is, positive moment. So again, if you input P here as negative, that means the load will act upward, and ENERCALC base plate module does not design base plates when they are subjected to pure uplift or net tension. So that's just something for you to keep in mind every time you're working on base plates. So on the right-hand side, also, there is a tab, that's the 3D tab. And the user will find this 3D rendering of their design that has all of the dimension, all of the information. This shows, of course, the columns, the applied loads, the overall dimensions of the plate, and overall dimensions of the concrete. And of course, the X and the Z axis direction. So you can see here, for example, the Z here, that's the negative, and this is the positive. So I know it's moving, but you can see where the positive is and where the negative is for yet another way of verifying that your input parameters, or of verifying the input parameters that you have inputted. And so we keep on progressing here left to right. The next item we have is, or the next step we have is the anchor bolts. So ENERCALC, and this is another thing that that's important to note, ENERCALC does not design anchorage or the anchor bolt themselves. So it will not size your anchor bolt for you, and it will not design your anchors into concrete. That means, it wouldn't look into your pull-out capacity from a concrete perspective, or edge distance in concrete, breakout, side blowout, all of that stuff. That's a whole separate thing. So ENERCALC doesn't do this. There's plenty of other useful tools out there. Hilti does a lot of that already. So that's what most people use. So ENERCALC doesn't do this. So however, ENERCALC gives you the option, or gives you the option to input what your tension capacity is of the anchor bolt. And what it says here, it says minimum of either the tension capacity of the anchor bolt or the pull-out capacity that's from your anchorage. So whichever controls, that's your maximum tension that your bolt can take. You should put that number right here. And that's the same thing. Your shear capacity that your bolt can take, that's based again on the bolt itself and the various limit states of concrete anchorage, or all of the failure modes. So you input this information that you put right here is going to be considered the allowable capacities of the anchor bolts, and they will be used whenever we make a comparison between, once we determine what is the maximum uplift or maximum tension per anchor, due to moment and all that stuff. Once we figure that out, we compare it to your capacity and we make a determination saying, yes, this is good, this is below your capacity, or that's more than what your allowable capacity is. So to get back to this, you have here a place to put a short description. Again, I'm using 1-inch diameter bolt and anchor rod, and that's grade 105. Now, of course, this is going to be a little bit of work on, to figure out using this. That's the reason why I knew that I want to use a 1-inch diameter bolt. So that's why, if you notice in the very beginning, I used 2 3/4 inch edge distance, because that accounts for the large hole that a 1-inch bolt needs. So long story short, you will input this information, your tension right here and your shear capacity right here, and a short description to remind yourself of what bolt you are using. And there are plenty of sources to get this information, but you can get it from the AISC to get that tension capacity from these bolts, or for these bolts. So moving on, we need to provide more information about the quantity of anchor rods, as well as their placement and edge distance relative to the edge of the plate, of course. So the edge distance in our example is 2.75, or 2 3/4 inches, and that's to account for a whole, a 1-inch diameter bolt needs a 1/7/8 worth of a hole in there. So that's why we're just choosing 2 3/4 inch edge distance. It is important to note that this module has the edge distance equal on both sides, so you can't have edge distance in the X direction that's not the same as the Z direction. That's one of the things that we have right here. The next two items here are very critical. Item number 1, it says number of bolts in each row. So we have a base plate that has 4 bolts, 2 on the top, 2 at the bottom, for example. Each row will get 2 bolts. And now it's asking you, how many rows do you have per side? We have 1 row at the top, so that side gets 1 row, and the bottom side gets another row. So for example, just to make sure that we all follow here, for example, if you have a base plate that actually looks like this configuration, the way that you will do this, the way you would model this, you'll say number of bolts in each row, that's 3. 1, 2, 3, because this is a row. Number of bolt rows on each side, we actually have 2. So we'll do 2. Now, if you have more than one row, so if you have 2 rows or 3 rows, you will get a whole nother input here that's called row spacing. So you can say the row spacing is 3 inches. In this example, we don't have any of this stuff, but I just want to make sure that you understand that you can input the number of bolts per row, and then you can input the number of rows that you need, that you're putting in your base plate. Again, in our example, we only have 4 bolts, very simple standard configuration. So we're ready to move forward. Now that we're done with the anchor bolt placement and location and all of that, we are ready to wrap up this calculation. We have load combinations. This is the same standard load combinations that you're familiar with. You can, of course, use a standard IBC, ASC combinations, or you can create your own. You have huge flexibility here in terms of customizing your own combinations, delete, add, modify. You can turn them on and off temporarily. You can reverse direction of wind load combinations and seismic combinations, so you can examine both sides and both directions. So you can do plenty of great work here with load combinations, just like what you can do with many of the other ENERCALC modules. Now we can finally get to a point where we can evaluate our results. Our results evaluation process, very simple here. So on the right-hand side, you have a calculations tab, and you get to pick the load combination that you want to evaluate, or you can pick overall results to show the enveloped results. So let's just stick to that, the overall results. That's the easiest. So we start on the very top right here. So that gives you a little bit of a summary on the base plate that you're using. It's allowable, ASD design method. It gives you a little bit of more information about the load case that controls. And of course, it gives you more information about the design base plate that you're using, which is, we're telling that two feet by 1 foot 10 inches. And again, right now I'm using like 1.9, I don't know, 1.9 inches or whatever. So it's 1 foot, sorry, 1 inch, 1 and 5/16 of an inch thickness. Next, you'll get a little bit more information about the plate bending stress ratio, as well as information about the plate bearing stress ratio. So you get this information right here. And right now, the stress ratio is at 99.9%. And again, this is because I picked the plate thickness to be the absolute minimum thickness required for this base plate to work. That's why I'm using, a weird number, 1.92. But of course, I'm not going to be going out and speccing a 1.92 thick plate. So you'll move forward and just kind of spec your detail will show a 2-inch plate probably, and just you'll move forward with that. So if you actually put a 2-inch plate, and if you update it and you put a 2-inch plate, then you get a 92% stress ratio, which is obviously better than the 99.9 that we had earlier. So we are good there. And lastly, ENERCALC reports the bolt tension stress ratio at 64.7. And you can see that the tension here, right? This is what matters really to me a lot, and to everybody, is that this right here, tension in each bolt, that is 24.5 kips. So personally, what I would do, I'll say, okay, my bolt works. The maximum tension is 24.5. I can just go and examine the anchors in concrete based on, based on this load. If I have 24.5 kips worth of ASD load, see how much embedment, edge distance, whatever I need to do to make sure that my concrete support, or that I can transfer the load to the concrete support below, whether it's my pedestal or concrete foundation or whatever. And if I need to add confinement or additional rebar to make this work, then we'll do that. So, but that's of course outside the scope of this module. So with that being said, pretty much you designed your base plate based on the requirements that they gave you. You know all your loads. Your base plate is good to go. And moving on here to wrap up our session, I want to talk a little bit about the steel bolt group analysis module. I use this module all the time. I use it with a lot smaller loads than what my example here shows, but I use this module very, very frequently for the work that I do. Very simple process to start this. Click on Add, click on Miscellaneous, and then of course you click on the steel bolt group analysis module. And once it opens, it's very straightforward. Again, you start here at the general tab, you give it a name, you pick your load combinations. We're using, and this is analysis, so this is load combination for analysis, not design purposes. So for analysis, again, I'm using just ASD load combinations. The example that we have is very generic right now, just a simple outrigger. We have 4 bolts. We have spacing of 4-inch in each direction. This D distance from the center of the group to the load that's being applied is 10 inches, and I am applying 500 kips worth of ASD dead load. The way that this would work is very simple. All you need to do is you tell it how many bolts you have. Once you tell it how many bolts you have, it'll give you these coordinates. You can simply just build them up. So you start with this one. This is 0, 0. Then, of course, 0, 4. And that's, the second one right here. And then 4, 4. And then 4, 0. So you just build them up. Very simple coordinate process. And next, once you have built these, the number of screws that you, or the bolts you have, you just go to the loads tab. Once you go to the loads tab, we input the load magnitude as 500 kips under dead load. That's, point load number one, load magnitude 500 kips. And then we input the application angle of the load. So starting at the positive x, so this is the x coordinate. Look at the positive side, right hand side, and you need to be at 270 degrees to get the load to point downward. You can play with this. Is like going counterclockwise. You can play with this to get this right, to get the load to point properly in the direction that you want it to point. Next, you are asked to put the horizontal distance from the datum. Again, our datum is 0, 0. The horizontal distance is going to be d plus this little amount right here. And because we know this is at, 4, 4, 4, so we know that this is just 2 inches. So 2 plus 10, that's why you put this as 12 inches. And the vertical distance from the datum, again, this is 0. So from 0 to here is 4, and then we add another 2 inches for this. So you're putting your load right here. That's the location of the load. So you can, of course, apply more point loads. That's point load number 2. You can apply more point loads here, and you can apply concentrated moments as well. So in our example, we're going to put the point load, and we're going to put the distance, and we're going to let it calculate, the torsion and all of that on our behalf. So as the case with all of ENERCALC modules, you get a dynamic 2D sketch that reflects the actual input data. So all of these dots with these coordinates represent your actual data that you inputted. And you can see here, this is the load. And if you zoom in so much, you'll see that the arrow is pointing down. It's kind of hard to show here in the slides, but you'll be able to see this very easily in ENERCALC graphically. So with that being said, it automatically calculates everything for you. It gives you here the load eccentricity, which is 10 inches from the centroid and 4 inches from the centroid of the bolt group, and it shows you here where the centroid is located from the 0, 0, which is 2, 2. Moving on, and this is kind of the evaluation of the results. For each bolt, the user will be able to see the direct shear right here, and you will be able to see the shear due to torsion, which is this right here in the X and Y direction. And then finally, you will be able to see the total bolt shear. Now, this actually, or ENERCALC accounts, of course, for the direction. So this means that, the direct shear sometimes acts in a way that adds or in the same direction, which makes it additive to the shear due to torsion. And sometimes they counteract each other because they're in the opposite direction. So that's why we do this does all of the work here for you, the positive, the negative, the resultant, all that stuff. And then now a total shear here on 1 and 2, for example, is going to be 365. And on 3 and 4 is going to be 537 kips. And again, if you don't know which one is 1 and which one is 2, you can always look at the sketch and it will tell you which one is 1, which one's 2, which one's 3, which one's 4, and so forth. So you can always have that sketch open and take a look to make sure that you are looking at the right bolt. So keep in mind that all of the input here is in kips. All of the input here, the results, and the input is all in kips right here. So just make sure that you're, if you have 500 pounds, it's a 0.5. It's not really 500, kips. Just make sure that you're consistent with your units. So before we end today, or before we jump into live Q&A, I just want to make sure that I would encourage everyone to register for office hours. It's a very simple process. You go to our for our users page on our website, get help, and then you register for office hours. You put your name, your license number here, your registration number is optional, and just click on remind me for office hours, future office hour sessions, and you'll be able to get an email reminder. And you can, of course, add it to the calendar, all from the same page. The same thing here for all of our previous sessions. We keep a recording of them and we put them on our website, so you can always check them out that way. The last one we did was the 2D frame module, and it's already uploaded So with that, I'm ready to open this up for live Q&A. I know we're at the end of the session, but we're ready to take some questions.
All right, let's go ahead and dive into our Q&A here. We had a lot of great questions today. First question, Mac, you know the answer to this one. You always pound the drum about this. Will the recording of the presentation be available for reference?
Yes, absolutely. Yes. So if you go, this is exactly what this is for. So if you go to our website, enercalc.com/office hours, you will be able to scroll down on that same page, and you will be able to find all of the previous recordings available for you and on that website. So yeah.
Perfect. All right, next question. Is there a way to have an auto option to select the plate like you do for beams and foundations? So the short answer to this one is no, not at this time. There's not an automated design option or an optimization like you do with some of your beam selection and your general footing size or your retaining wall footing width. There's a lot of variables in this case, including your gross plate geometry, your section size, your number of bolts, bolt spacing, etc. You can manually iterate the thickness like Mac went through. If you have a request, like a feature request, if there's something you want to see integrated in the future, absolutely send that over. All of our feature requests go to the engineering team via support@enercalc.com. Matt, go ahead if you have questions about that.
Yeah, no, your answer is absolutely right. And just want to add that in the design guide, they have a little quick trial, come up with a trial plate size or dimensions, which is, if I remember correctly, it's like the width of the column, and then you add the edge distance, and you add 2 inches or something like that. So that always can be, the back of your pocket, and that would be your trial size to start from, and kind of go from there. But yeah, unfortunately, just there's so many solutions that could actually work. It could be a 20-inch plate by 24, or it could be an 18 by 16. You can just end up with so many different things that it's kind of hard to optimize in a way that actually ends up making sense to the engineer.
Right. Mac, we have a bunch of new features that you went over, and I don't remember if you touched on this one, but I'll give you a chance to jump in if you want to show this one. So the question is, I sometimes need to directly compare two different ENERCALC calculations. Is there a way to perform my own post-processing on results data? We have some new behavior in the outputs of the beam module that kind of answers that question. So if you haven't seen, or if you guys aren't familiar, and Mac can show this on his end if he wants to, in all of our beam modules, we have a new feature where you can access a right-click context menu on all of your tabular outputs from an ENERCALC beam module. So you can basically save as to a CSV file or copy and paste out to an Excel file. So you could actually take results from a beam calculation or, for example, steel beam, concrete beam, etc., copy that out to an Excel file and do your own post processing if you needed to. So we can go through that back if you want to, but that's just good to know.
Yeah, I'll let me open here calculation. But yes, and just to kind of show you a quick idea before I get into this, that's what it's looked like. Once you find the calculation that you want in a like steel beam, you can right click on the calculation. You
Exactly.
can say save to CSV or copy to clipboard. You can do some work there. But let me pull it up here while I create a new calculation because I don't have a calculation ready. But we can go to the next question while I do this.
Yeah, for sure. So another common question, there's a lot of new updates. Is there a place where you can see all the updates listed, which is a great question. Updates.enercalc.com will take you to our release notes page, and you can always see the full rundown of what's happening in our latest version releases at that location. So updates.enercalc.com. I'll go ahead and drop that in the chat just so everybody has it.
Do you see my
There you go.
screen?
Yeah, that's
Yeah,
perfect.
so if you have a calculation that's already built up and you can get into, your information here, and you can kind of you can click on whatever you want, and you can say save to CSV, and that will save all this stuff for you as a CSV file that would help you to do some of that comparison.
Perfect. All right. Question about um, the steel bolt group analysis. Would you be able to change the direction of the load?
Yes. Let me know. Exit out of this real quick. Yes, you can. That's exactly what the whole point of the angle application. So let me show you here. That's what I was. So if you open this and let me open the sketch. So right now this is pointing downward. What I can do, I can just say this is 180, and that will change the load to point towards the left. I can do 0, and that will make the load point to the right. And of course, I can do 90, and that'll make it point upward. And I can actually bring this load whatever I want. So right now, the load, let me change this back to 270. So the load right now follows my example. It's applied, acting downward, applied right here on the trigger, on the outrigger. And maybe you have it on the opposite side. So you can just do -12, and it'll actually come on the opposite side. Maybe it's a little bit lower. So maybe that's at, um, you know, 4 inches. So maybe it's a little bit lower. And maybe you don't have a nice clean angle. Maybe it's a weird 230. That's where your load is applied like that. So it'll do all of the analysis and come up with all of that X and Y component. You see that the direct shear right now shows you what your X is and what your Y is. Compared to my example earlier, the direct shear was only in the Y direction because it was just perpendicular. As you can see, it's right here. If I turn it back to 270, which is the vertical, the straight up vertical like that, then X is completely 0 and Y is 125, which is 500 divided by 4. So you can do whatever your heart desire as far as this goes.
Perfect. And then the follow up question to that is, can you also achieve those changes or similar changes by placing a negative sign on the load magnitude itself?
That's a good question. Let's try it.
I believe you can.
Here. No, I don't think so. I think it's just because it's all controlled by the angle, by the application angle. It doesn't. I don't think it changes here.
Gotcha.
Let me do one more thing here just to make sure that my numbers. Ah, well, never mind. I stand corrected. If you do the negative sign here, it will do the calculation correct, but it does not visually show it. So
Gotcha.
I wouldn't do that. I would just visually apply everything properly so I can see everything right. If the arrow is pointing to the right, then it's 0. If it's pointing to the left, it's 180. I would rather use that to make sure that I'm a visual person, so I have to see it right in order for me to visualize it and be able to compare and assess the results. So, but yes, if you put a net, like if you look at it here, for example, the torsion, the shear due to torsion in the X direction right now, it's 26.5 and it's positive. And if I change that, it will change to minus or negative 62. So it's definitely doing it right, but it's not adjusting the visual display. So I wouldn't use that. I would just stick to using the angle of the application angle.
Perfect. All right, next question. When are welded connection coming? So, for those who may not be aware, the capability that Mac is showing here, steel bolt group analysis, is actually not a new capability. That module has been in ENERCALC for a long time, so that's not a newly deployed tool. We don't have any additional steel connection design capabilities in active development right now, but if that's something where you have a feature request, you want to talk to the engineering team about that, you can absolutely send those feature requests to support@enercalc.com. But just to be clear, that's
Yeah,
not a brand new feature that Mac was going through
yeah,
today.
I want to say, yeah, I have personally, at least from my personal experience, I have been using this particular module since probably 2016. So it has been there for a while.
So a follow-up question on that one, Mac, can the steel bolt group analysis be applied to other materials? So my recollection is that the behavior of this module is material agnostic because it's a static analysis of the bolt group. But go ahead if you have thoughts on that.
Yes, the answer is yes, 100%. All of my work, I practice heavily in cold form steel, and my numbers are not. That's why in the very beginning I said my numbers are typically a lot smaller. My numbers are typically like 500 pounds, and I have a cold form outrigger, and I have to design screws that are going to take 200 pounds worth of load. So this is a complete analysis tool. It has nothing to do with the actual design. So once you do this, then I take the number and I go and separately design the screw shear, the bearing of the material, and all of that connection design stuff that we already know. So this one, just an analysis that tells you how much load is going into your screw or your bolt, and designing the bolt and designing, of course, the bearing material where the bolt is bearing on. That's something different. So to answer your question, yes, 100%. This is has nothing to do with the material we're using. It's just analysis tool.
Yeah, and you run into similar implementations with dowel type fastener connection design in wood materials, for example. If you're doing
Yeah, that's right.
bolt groups in wood have a similar geometry, and you have to go through a similar load distribution analysis.
Yes. And typically, this is really useful whenever you design something, you tell them to go and put, screws at 4 inch on center, and you have this nice, beautiful detail that tells them where to put their screws. And then they send you a picture from the site, and it sounds like somebody just vomited on the surface with a bunch of screws in different dimensions. Then now you need to come back and analyze whatever they just did with very weird geometry, very weird layout, and this is a huge time saver in that regard.
All right, next question. Along with base plate, can ENERCALC provide anchor bolt specifications like heavy hex, Titan HD, etc.? So this is a question that we get asked from time to time, which is fundamentally, is there a way that ENERCALC can make it easier for engineers to specify commercially available products? That's definitely something that we continue to talk to vendors like Simpson Strong Tie about, figuring out ways that we could make that specification process easier for customers. Right now, what you're getting out of the analysis that Mac walked you guys through is the demand on those anchors. You can get tension and shear on those anchors, but we're not doing an ACI breakout analysis or anything like that.
Absolutely.
All right, next question. If there's a moment from wind load applied to the column and beam connection, where exactly should we be able to apply that load? Oh, okay, there's a second follow up. If there's a shear from wind load applied to column and beam connection, where exactly should we apply the load? So that sounds like it's in reference to your eccentric bolt group analysis rather than the base plate analysis. But go ahead with what you're showing there.
Oh, is that for base plate, or is that for if the moment when load applied to column and beam connection? Where? Okay. Do you think this for the base plate, or do you think for the other one?
It sounds like that's in reference to your eccentric bolt group.
Okay. Let me go back and read this again. So
Yeah, so
there's a
there is a
moment.
field, in addition to the eccentric forces, there is a field in the bolt group analysis to explicitly apply a moment.
Yeah, so that's what I want to show here. So let's go back here and make sure that we answer this. So you have the ability to enter 2-point loads and concentrated moment. Okay. So if you have, let's say, a point load that is, from wind, then you can put that right here. But what I want you to know is that if you apply this load with the eccentricity, then it automatically calculates the moment. You don't have to go and superimpose another moment again. Now, if you do have a true concentrated moment somehow that's not associated with any, vertical or horizontal load, just a pure moment, you can apply a pure moment separately right here. Does that make sense? What I'm trying to say, Seth, here?
Mm-hmm.
So yeah, so if just you have some sort of a wind load that's being applied, and you already apply it at an eccentricity from the centroid of the bolt group, then that already has, ENERCALC will already calculate the moment effects of that and make sure that it grabs make sure it grabs the shear as well. So that's why you see here that says direct shear. That's pretty much taken 500 divided by the number of bolts. That's direct shear. And then it shows you the moment right here, and then it shows you here the torsional shear. So this is the total moment that you're getting because of that load. And then that load is getting, analyzed to get the shear due to torsion from that. Yes,
All right.
you can do He said, "You can you do lateral?" Because that's the follow-up
Yes.
question. Sorry. Can you do lateral and vertical load at the same time? The answer is yes. I'm gonna go ahead and put two kips, and I'm gonna do a load application of 90 degrees, and let's. Oh, that's 90 inches. Sorry. I'm gonna have to look into this because I'm not seeing. One second. Where's all this?
Yeah,
There
it
we
would
go.
just be your second row. There you go.
There you go. Yeah, it just kind of took me a second there. Let me do this at 180. There you go. Sorry, took me a minute. And let's say you want to put this at, if you want to put something like this, do it like that. If you have a horizontal load that's coming like this and you have a vertical load coming like this, all of that is going to get accounted for.
Perfect. And again, if we ever run into questions where you guys feel like you haven't adequately gotten your question answered, always don't hesitate to reach out to the support team. Our final question for today: since the base plate module doesn't take net uplift, does that mean we do not select automatically create load combination using opposite sign? Does not necessarily mean that. A lot of times in a column design situation, your greatest vertical, your axial forces are not going to come from wind and seismic, although they could in the case of a braced frame. In some cases, it may be desirable to still consider reversal of your lateral shears at the base of a column. For example, still reverse your wind and seismic. Um, if you do have your controlling axial force coming from wind or seismic, then yes, you have to be aware that that could result in net uplift. But that doesn't necessarily mean that you should dismiss out of hand the checkboxes to reverse those options. That's kind of up to the individual engineer when you're tackling a particular.
And I want to add one thing to this, Seth, to
Mm-hmm.
at least to put everybody at ease. ENERCALC doesn't hide it whenever you're in net uplift. If I switch this to net uplift, ENERCALC tells you net tension, no calcs, it goes crazy. So you're not gonna miss it. If you have the reversal of the lateral loads, and if that results in a controlling case where the net tension is controlling, it will immediately tell you. It's not gonna hide it, and you're not gonna be fooled by phony results. It'll tell you we're not going to do this.
Right, for sure. And then you still have the option to consider reversal of your lateral VZ shears, even in the case where your controlling axial force comes from something other than those wind and seismic. So using the reversal checkbox does not necessarily mean it's going to break your results or halt calculation like Max showed there. All right. Well, we are about 15 minutes after the hour, but we definitely enjoyed
Wow.
all the great discussion. Mac, do you want to close us out with some final information about next month's office hours session?
Yes, I just want to thank everyone for their time today, and yeah, we took a little bit of extra time to answer questions, but we try our best to help, and we're excited. Our next session is on May 14th. It's also a Wednesday, of course, May 14th, and the topic is still to be determined. So if you have any suggestions, we're actually we're definitely open for suggestions because we haven't picked what our topic is going to be for the next session. So let us know. Otherwise, we'll pick something and let you know. But either way, May 14th.
Yeah, as always, if you guys have a question or a topic you'd like to see covered in a future office hours session, you can email officehours@enercalc.com and Mac will be able to go through there and look at all the different topics that engineers are interested in seeing. So, as always, we thank you all for being here. We enjoyed the great discussion. Great to stay in contact with all of our customers who come in every month to discuss. So, we will look forward to seeing you guys next month with another great topic. So, thank you all very much and have a great day.
Thank you.